Understanding the NIC buffer and data handling with recvfrom in raw sockets. Introduction. When working with raw sockets in network programming, it's critical to understand how data flows from the network interface card, NIC, to your application. Raw sockets require you to handle received data manually, but how exactly does this process work behind the scenes? How data moves from NIC to application. NIC buffer. Incoming packets are first stored in the NIC hardware's internal buffer, often implemented as a ring buffer. Kernel processing. The operating system, OS, kernel reads this data from the NIC buffer and processes it. Socket receive buffer. The kernel places processed packets into the socket receive buffer associated with your raw socket. User space buffer. When you call recvfrom, the data is copied from the kernel socket buffer into your application's buffer in main memory. Does recvfrom move the NIC buffer read pointer? The read pointer movement occurs at different stages. NIC ring buffer pointer, managed by the NIC and OS driver, advancing as packets are consumed into the OS. Socket receive buffer pointer, managed by the OS kernel. When your application calls recvfrom, data is removed from the socket receive buffer. Your call to recvfrom only advances the read pointer of the kernel's socket buffer, not directly the NIC hardware buffer. The kernel driver handles NIC buffer pointer advancement separately. Example clarification. If your NIC ring buffer holds 2 packets, the NIC and driver move packets into the kernel socket buffer independently. When you call recvfrom, you read from the kernel buffer into your application's buffer. Multiple recvfrom calls read sequentially from the kernel buffer, but NIC buffer pointers are managed by the kernel/driver. Summary. NIC buffers and their read pointers are hardware and driver managed. The OS kernel copies data from NIC buffers into the socket receive buffer. Your raw socket application calls like recvfrom read data from the kernel socket buffer to user space and move that buffer's read pointer. Understanding this separation clarifies how packet data flows and which components manage the different buffers involved in raw socket communication.